We've got this setup, 8 squares, 1 large unshaded squares, 4 small unshaded squares, and then 3 shaded squares. I'm asked what fraction of the area is shaded. So we're not given any lengths, but of course they're sort of linking together so we can, maybe figure out the length in terms of one another. I'm going to talk about two different ways to do it. First way is just to say that the length is x. That's, it's quite often a good shout in maths when you don't know what something is, just give it a name. And x is typically what we use for, you know, for maths problems, and we then create equations in terms of x. You don't have to call it x, you can call it something else if you prefer. So all of these are going to be x, and that immediately tells me that my big square will be 4x in height. So I'll just put an arrow in it to show that it's not the whole thing. But you can see the whole thing's actually going to be 5x. Now, I can then work out the length of one of the shaded squares. It's going to be 5x divided by 3. The problem with that is that I've introduced fractions. You can go with it, there's no problem with that, but I'm actually going to modify the problem at this point. And because 3 doesn't go into 5, what I can do actually is just make all my small squares 3x. So make it so, basically they are a multiple of 3, which will then change my 4x into 12x. And then, well, this will be 3x as well. So we'll get 15x. Okay, that's great because now I can see that this is 5x. And therefore this is also 5x. So what we have is this rectangle that is 15x times 12, 17x. That's going to be the area of the really big rectangle. And then I'm going to have 5x times 5x for the area of one of the shaded squares. I just need to times by 3. So what we see is that the x's all cancel. It's actually independent of x. And then 3 times 5 will cancel with the 15. I can do that. Of course, you can multiply it all out and then cancel it down, but this is far better. And then we're left with simply 5 over 17. Nice. Now I'm just going to go through this question one other way. Actually, algebra is not always important. It's like because we're dealing with a fraction here, it must be that the fraction doesn't depend on the size of the rectangle. Like there's no way it can. As we enlarge the rectangle, make it smaller, the fraction is going to stay the same. So we can, in fact, instead of just calling it x, we could start with 1 as the length of the square. Then this would be 1, this would be 4. We're going to get 5. Now we have 5 over 3 again. Okay, I'm doing this sort of from the start, but actually let's scrap 1. Let's go with 3. So I'm basically doing exactly the same thing, but I'm just avoiding having to use x. And you might prefer it if you don't like all the x's and all the algebra that went on here. Just say that just name a length. Because we're dealing with the fraction, it will all be okay. And now, so this is going to be 15 in total, so each of these will be 5. And then we're basically back to where we were. We've got the total amount, that's 5 as well, is going to be 15 times 12 plus 5, so 17. And then again, we've got 5 times 5, but there's 3 of them. So you can see it sort of mirroring what we did before. These two cancel, and we're left with 5 over 17.